Chapter 1. Understand the concepts of programming. Computer languages. We know by now that a computer is an electronic device that uses power to process the given data and instructions. It cannot do anything on its own, but it works according to the instructions given by the user. It does not understand the language used by us but has its own language. Therefore, to enable the computer to perform any operation, data and instructions given to the computer must be in a language understandable to the computer. Computer languages have progressed over the years just like computer hardware. Starting from the language made up of just two symbols, that is, 0 and 1, binary numeral system. Today we can write computer programs by using common English and mathematical terms. Computer languages are classified into two main categories. Computer languages: low-level language, high-level language, machine language, 1GL, assembly language, 2GL, third-generation language, 3GL, fourth-generation language, 4GL, natural language, 5GL, low-level language. These programming languages mainly designed to operate and handle the hardware known as low-level language. There is no translation is required because the codes and applications are directly executable on the computing hardware. Low-level language instructions created for one kind of computer will not function on another type of computer with a different design. These languages are also called computers' native languages. Machine language, 1GL. Machine languages consists of binary digits 0 and 1, where the bit 0 represents the off state and the bit 1 represents the on state. Computers can directly understand the machine language. Assembly language, 2GL. These languages are developed to overcome the drawbacks of machine language. In assembly language, codes are written in the form of alphanumeric symbols called mnemonics instead of binary digits. For example, for addition, subtraction, and multiplication, it uses symbols like plus, minus, and multiply. High-level language. These programming languages are designed to allow programmer to write codes and interact with the computer system without knowledge of the processor or hardware that the program will run on. It means that these languages are easier to read, write and maintain. These languages are machine independent. It uses English-like statements to write instructions. They are widely used because they are easy to understand to human beings. Third-generation languages, 3GL. These programming languages consist of the use of a series of English-like words that people can understand easily to write programs or instructions. These languages need a translator to be translated into machine language for execution. Basic, COBOL, Pascal, Fortran, C, C++, Perl, Ada, Java are examples of third-generation languages. Fourth-generation languages, 4GL. Fourth-generation languages are non-procedural languages. It means that the programmer defines what is needed rather than how it is to be complete. These languages reduce time, effort, and cost of software development. SQL, Oracle, PostScript, Informix 4GL are examples of fourth-generation languages. Fifth-generation languages, 5GL. Fifth-generation languages are the natural languages. They are used mainly in artificial intelligence or expert system. OPS 5, Mercury and Prolog are examples of fifth-generation languages. Language translator. A language translator is used to convert a high-level language program into a machine language. Let's discuss the types of language translator. Source code, translator, object code, assembler. An assembler translates the program written in assembly language into machine code. The source program is an input consisting of assembly language instructions. The output generated by the assembler consists of object code or machine code. Compiler. A compiler converts the entire source code into executable machine code. It takes a large amount of time to analyze the source code, but the overall execution time of the program is faster. Interpreter. An interpreter translates a source program and runs it line by line. It moves on to the next line for execution after the removal of the error of the existing line. It needs less memory as compared to the compiler. Algorithm. An algorithm is a set of rules or instructions created for completing a particular task. It consists of a series of actions that the computer must take in a particular order in order to solve a problem. Calculations, data processing, and decision-making all involve algorithms. A programmer first creates the steps for the task or problem before creating the computer program to solve it. Writing the algorithm before writing the program makes it simpler. Write an algorithm to bake a cake. 1. Start. 2. Preheat the oven. 3. Collect all the ingredients. 4. Mix together the ingredients and make batter. 5. Grease a pan and pour the batter into the pan. 6. Place the pan in the oven. 7. Set a timer to bake. 8. Take the pan out from the oven. 9. Enjoy the cake. 10. Stop. Write an algorithm to calculate the sum of three numbers. 1. Start. 2. Read three numbers and store them in X, Y, and Z. 3. Add three numbers X, Y, and Z. 4. Print the sum. 5. Stop. Write an algorithm to calculate the average of three numbers. 1. Start. 2. Input three numbers, num1, num2, num3. 3. Calculate the sum. Sum is equal to num1 plus num2 plus num3. 4. Calculate the average. Average is equal to num1 plus num2 plus num3 is divided by 3. 5. Output the average. 6. End. Flowchart. Flowcharts are the graphical or pictorial representation of the data or the algorithm for a better understanding of the code. These are mostly used by beginner-level programmers to easily understand the algorithms. These use particular geometrical shapes to represent actions that must be followed to complete a specific task. These shapes are called symbols. Flowchart symbols. Let's learn about the various flowchart symbols with their descriptions. Symbol. Name. Description. Input-output. It is used to represent for reading the input or writing the output. Processing. It is used to represent the processing of the input provided. Decision. It is used to represent if there is a choice between two options. It also has two flow lines which shows yes and no, or true or false. Flow lines. These are used to represent the direction in which the process or steps are moving. Terminal. It represents the starting point and ending point of the flowchart. Connector. In some cases, a flowchart doesn't fit into a single page, then you need to show connectivity between the two pages. To resolve this problem, connector symbol is used. Rules to draw flowcharts. You should follow some basic rules while drawing a flowchart. Let's learn about them. The flowchart should be neat and clean. The direction of the flow from left to right or from top to bottom should be maintained properly. Only one flow line should come out of a process symbol. Only one flow line should be entering a decision symbol and two flow lines should exit from the decision box. Drawing flowcharts. Now draw some flowcharts. Draw a flowchart to calculate average of three numbers. Draw a flowchart to calculate area of rectangle. Start. X, Y, Z average. Read X, Y, Z. Average is equal to X plus Y plus Z, 3. Write average stop. Start. Read length, breadth. Area is equal to length into breadth. Print area. End. Draw a flowchart to print the value of X from 1 to 10. Draw a flowchart to print whether a number is even or odd. Start. X is equal to 1. Is X is equal to 10? Yes. Print X. X is equal to X plus 1. No. Stop. Start. Read N. If n%2 is equal to 0. Yes. Print even. No. Print odd. Stop. In summary, computer languages have progressed over the years just like computer hardware. The programming language that is mainly designed to operate and handle the hardware is known as low-level language. Machine languages are very difficult for coders because it consists of binary digits 0 and 1. High-level programming languages are designed to allow programmer to write codes. Third-generation programming languages consist of the use of a series of English-like words that people can understand easily to write programs or instructions. Fourth-generation languages are non-procedural languages. It means that the programmer defines what is needed rather than how it is to be complete. Fifth-generation languages are the natural languages. They are used mainly in artificial intelligence or expert system. A language translator is used to convert a high-level language program into a machine language. Flowcharts are the graphical or pictorial representation of the data or the algorithm for a better understanding of the code.